Hello viewers, in today's session we are going to discuss another important and very conceptual problem from definite integrals. And in this session we are going to discuss this problem where we are given a function f which is defined from this set, that is the closed set from 0 comma 1 to the set of real numbers, and we are given this integral, that is 0 to sine x f of t dt is equal to square root of 3 divided by 2 pi x square, and we have to find the value of f of half, right? So here in this session we are going to make use of the famous Leibniz integral rule to solve this problem, right? So let us first see the statement of Leibniz integral rule, and then we'll see how we can easily solve this problem using the concept of Leibniz integral rule, right? And moreover here this domain, that is the function f has this domain, that is the closed set 0 comma 1, and this domain is going to play a crucial role, right? So let us start. Now, Leibniz integral rule states that if we have an integral whose upper and lower limits are functions of x, suppose the lower limit is u of x and the upper limit is v of x, and here we have a function f of t, and here we have dt. Now, suppose we wish to differentiate this integral with respect to x, then Leibniz rule says that first we'll replace this t by the upper limit, that is v of x. So we have f of v of x, and then we differentiate this function v of x with respect to x, then we have a negative sign, and then we replace this t by a u of x, so we have f of u of x, and then we differentiate u of x with respect to x, right? So when we have a function f which is a function of only t, right? So here we are considering this function f of t only, right? So then this Leibniz integral rule goes like this, right? So here we are given this integral, that is 0 to sine x f of t dt, and here we have square root of 3 over 2 pi x square. So here the lower limit is 0 and the upper limit is sine x. So the upper limit sine x is a function of x. So we'll differentiate both sides of this equation with respect to x. So now differentiating both sides with respect to x, we can write d by dx, and here we have 0 to sine x, and here we have f of t dt, and in the right hand side we have d by dx of square root of 3 over 2 pi and x square, right? So if we compare this integral with this one, then u of x is 0 and v of x is equal to sine x, right? And if we apply this rule, then the left hand side can be written as f of v of x. V of x is sine x, and then we differentiate v of x with respect to x, so we have d by dx of sine x, then we have the negative sign, then we have f of u of x. U of x is 0, and then we differentiate u of x with respect to x, so we have d by dx of 0, and in the right hand side we have square root of 3 over 2 pi, and the derivative of x square with respect to x is 2x. So now simplifying this side, we have the derivative of sine x as cosine x. So we have f of sine x, and here we have cos x, and this term is 0 because here we have 0, and now we can write root 3 over pi, because this 2 and this 2 get cancelled, and here we have x, right? So using the Leibniz integral rule, we have arrived at this equation, right? Now see here, we have to find f of half, right? So here the input is half, and here we have f of sine x, right? So in order to get the value of f of half, let us replace sine x by half, right? So taking sine x is equal to half. This equation is now taking the form f of half, and then we have cosine x, and here we have root 3 over pi, and here we have x, right? So now we need to find out the value of x, and to get the value of x, we'll utilize this relation, that is sine x is equal to half, and this is a trigonometric equation. So sine x is equal to half. It gives us x is equal to pi by 6, because sine of pi by 6 is equal to half, right? And we can see that this x, which is equal to pi by 6, it belongs to this interval, right? So pi by 6 belongs to the interval 0 comma 1, and if we find out the value of pi by 6, then it is approximately equal to 0.523, and 0.523, it belongs to this interval, right? Now see here, sine x is equal to half is a trigonometric equation, and we know that sine x is a periodic function with period t is equal to 2 pi, right? And sine x is equal to half has many solutions, but here x is equal to pi by 6 is the only solution which belongs to this interval or this domain, right? So we have to take only this value of x, that is pi by 6. So now taking x is equal to pi by 6 in this equation, we have f of half, then we have cos of pi by 6, and here we have root 3 over pi, and x is pi over 6. And this pi get cancelled, and we have f of half, and cos pi by 6 is cos 30 degrees, that is equal to root 3 over 2, and here we have simply square root of 3 over 6. So now we can rearrange the terms. So we have f of half is equal to root 3 over 6 multiplied, and here we have 2 over root 3. Now root 3 and root 3 get cancelled. Here we have 2 times 3 is 6. So we are left with 1 over 3. So viewers, the required value of f of half is equal to 1 over 3. So this is how, by making use of the Leibniz integral rule, we can solve these kind of problems comfortably.